Hello, ladies and gentlemen. We are on our next set of notes called the characteristics of quadratic graphs. So, a quick reminder that our quadratic functions is a equals ax squared plus bx plus c, where a cannot equal 0. So, think about this. If a equaled 0, 0 times x squared is then there's no more x squared, then there's no more quadratic function, and it would just have the bx, which would just then be a linear function. Okay, so again, we need to have that ax squared to be able to have a quadratic function. Today, what we are going to be talking about is we are going to be talking about intercepts, zeros, axis of symmetry, a little bit about our extrema, which deals with the vertex minimum and maximum, and the end behavior. And this is your domain and range. Okay? The first thing I'm going to have you guys do is go ahead and define the definition of a parabola. I know you guys are pretty familiar with this. We talk about it quite a bit in class, but again, this is a U-shaped figure, a U-shaped graph. Once you have that copied down, let me have you copy down intercepts. Intercepts are where the graph intersects the x and y axis. Once you have that copied down, please copy down axis of symmetry. This is the vertical line through the vertex. Okay? And this is actually also going to be either an x equals some number, and it's also located where we have our vertex. So the vertex is the point at which the graph turns around, also known as our turning point, the location of a minimum or a maximum. Okay? And that is our extrema. So pause if you don't have this copied down. I'm going to switch papers here very quickly on you. So what we're doing now is we are going to now find values of a quadratic function without graphing. Okay, so we're going to do all of this algebraically. I will be giving you a quadratic function. Remember, our functions either start with f of x or y. The first thing we're going to do is we are going to solve for our intercepts, the y-intercept. So when we are solving for the y-intercept, we are going to remember that our x value is 0, and we're going to have some value for y. So to do this, what we're going to do is we're going to put 0 in for x and solve for y. 0 squared minus 8 times 0, which is 0, leaves us with 15. So y is equal to 15. Our very last step is we're going to write this as an ordered pair, so we have 0, 15. Next, what we're going to do is we're going to talk about the x-intercept. Let's quickly remember all the names for the x-intercept. It is also known as zeros. It is also known as roots and solutions. Okay, and this is, again, we're going to put 0 in for y and solve for some value of x. When we do this, 0 in for y, or in this case it's f of x, we have x squared minus 8x plus 15. The same strategies that we did before, where we're going to see if we can factor this easily. If we cannot factor it easily, we will complete the square, or we will use quadratic formula. Factors of 15 that add to negative 8. We have x minus 5, x minus 3, still equal to 0. Then we set each factor equal to 0 and solve for x. So x equals 5, x equals 3, and then we're writing them as intercepts. So as an ordered pair, we have 5, 0, 3, 0. And at this point in the school year, if we are not writing them as intercepts, they will be wrong. The next thing that we're going to do is we're going to find the axis of symmetry. The axis of symmetry uses the same formula that we use for the vertex. Okay, so we're going to make our substitutions. We have negative 8 for our b over 2 times a, which in this case is 1. We're going to simplify. We have 8 over 2 which is 4. Now what we did is we found, if I have a parabola, the axis of symmetry goes right through it at the turning point. And that turning point is going to be x equals 4. It's always going to be some x value because it connects with domain. Domain moves left and right. It will never include your y. To find the vertex, remember you will start by using the same formula. Okay, but we found it from the top, so we know that x is 4. Okay, and this is, the same thing that we did up there. But we are now going to find the y value. The y value, we're going to substitute 4 in for our x. So we get 4 squared minus 8 times 4 plus 15, which is 16 minus 32 plus 15. When we simplify this, y equals -1. We're going to write this as an ordered pair. 4, -1. This is my vertex. My vertex. Okay. Let's go ahead and flip the page. We're using the same function that we had on the first page. F of x equals x squared minus 8x plus 15. Okay, we're going to state the minimum or maximum values. Now actually, I'm going to do these notes a little bit differently. We'll come back to this. Let's jump to the third page. So I'm sorry, we're going to kind of jump around a little bit, and we're going to do number 4 and 5 first together. So for number 4, it says find the zeros of 2 and -4 and a maximum of -1, 5. So we know what zeros are. Zeros are our x and y intercepts. So I'm going to find this on my coordinate plane. Here it is, 2, 0, and then -4, 1, 2, 3, 4. I have -4, 0. -1, 5. Let's go ahead and plot that. -1 and up 5. 1, 2, 3, 4, 5. This is also my vertex, this maximum. Okay? I'm going to go ahead, connect my dots. It is known as my maximum because it is the highest point, the largest point of this quadratic function. Let's try this again for number 5. So my zeros, my x-intercepts, are 2 and -4 again. So I'm going to go ahead and find 2. And then find -4. 1, 2, 3, 4. Label your points. And then this time a minimum of -1, 3. So I'm going to go down, left 1, and then down 1, 2, 3. I'm going to sketch my quadratic function, my parabola. Okay, and so this is known as a minimum, okay, because this is the lowest point of my quadratic function. Okay, so again, use the concept of a minimum, maximum, and try to apply it to these quadratic functions as they are graphed, okay, so as they're parabolas. So coming back to that second page where I stopped, okay, we're going to state whether it has a minimum or a maximum, okay, and state the value. And really, as of right now, with not graphing, we have to kind of sketch this graph like we just did for problem 4 and 5. So I'm going to sketch in my coordinate plane. I'm going to think back to my zeros that I got on that first page. Okay, so the zeros that I have are 5, 0, 3, 0. So I'm going to go ahead and mark it was 3, 0, 5, 0, and then the vertex is 4, -1. So I'm going to go ahead and plot in, okay, so 4, -1 is right about there. And then if I would sketch my parabola, This right here is my minimum. And the value is 4, -1. Okay. The last thing that we are going to do on this part is talk about the domain and range. And we're going to use that sketched graph to help us come up with our domain and range. Domain and range is looking for an starting or stopping point going left to right. We have no indication that this parabola is going to stop on the left or stop on the right. So we're going to go ahead and say we have -infinity. I'm going to write it so it's less than x, which is less than infinity. The range, actually, this parabola does not start until -1, less than or equal to y, but it goes on. These arrows tell me that it's going to go on forever. All right. Let's try this again for number 2. So for number 2, I have -x² minus 6x. The first thing we're going to do is look for our x and y intercepts. I am going to go ahead and start with the y-intercept. To find my y-intercept, I'm going to put 0 in for x. So -2 times 0 squared minus 6 times 0. And I simplify, I get 0 minus 0. So y equals 0. I'm going to go ahead and label this that my y-intercept is 0, 0. Now let's do the x-intercept. This time I'm going to put 0 in for y and solve for x. For this one, I do not have a trinomial. I cannot do trinomial factoring. And because I have this variable here, I cannot do the square root method. So what I'm going to do is I'm going to factor out a 2. But I'm going to go ahead and factor out a -2 because I just like working with that first term being positive. So -2x squared divided by -2, I now have a positive x. And then -6x divided by -2x is a positive 3. Then you set each factor equal to 0. So I have x equals 0, and then x equals -3. So I'm going to go ahead and label that my x-intercept is equal to 0, 0, and -3, 0. The next thing we're going to do is axis of symmetry. Remember, we're going to use that vertex formula. It works for both axis of symmetry and the vertex. So I'm going to start with x equals -b over 2a, just recopying that formula. My b is -6, so it's negative times -6 over 2 times -2. That leaves me with 6 divided by -4, which is -1.5. My axis of symmetry is x equals -1.5. Again, this is a vertical line, so it lies right on the x-axis at -1.5. My vertex. This right here is the x-coordinate for my vertex. Okay? And so y equals, I'm going to go ahead and find the y value. I'm going to use my x value of -1.5 for that vertex. And I'm just making my substitutions. I'm going to simplify and solve. So -1.5 squared is positive 2 and 2/5, 2 1/4. Then I have positive 9. I keep simplifying. I have y equals 4.5 plus 9, which is 13.5. So the vertex, as an ordered pair, is -1.5. Again, it connects with the axis of symmetry, and 13.5. All right. Now state the minimum or maximum. And this is, again, we're going to do the same thing. We're going to go ahead and sketch this like we did on our first problem. So I'm going to go ahead and draw a coordinate plane off to the side. I'm going to start with my intercepts. So I have 0, 0. Then I have -3, 0. -3 zeros over here. my vertex is negative 1.5 and then positive 13.5. So it's going to be up here somewhere. And then now, this time I have an upside down parabola. With an upside down parabola, what I have is a maximum. And to name its value, I name the location that I have my maximum, which is also known as my vertex. So it's negative 1.5 and 13.5. Hey, I want to point something out real quick before we go on and do domain and range. Here we go, trying to squeeze it all in. You see how my AX right here is negative? Whenever I have a negative, I'm going to have an upside down parabola. You think about all those projectile motion and falling object problems, story problems that we did, it was almost always like negative 16t squared because we were always like throwing something up and then it was coming back down. Over here we have a positive AX squared, and so here my parabola is right side up, kind of like what we're used to seeing. So we're going to spend more time on this, but you are going to have to remember positive AX squared, my parabola is like this right side up or smiley face. Negative AX squared, I'm going to have a parabola that is upside down or frowny face, however you want to think about that. Okay, so to finish up number 2, we're going to go ahead and label our domain and range. So we have domain. Use the graph that you sketched. Does not look like we're going to have any starting or stopping point. So we're going to do negative infinity to positive infinity, and then we're going to do range. And it starts, my arrows tell me, at negative infinity, but it's going to stop at 13.5. Okay? And tell you right now, our next set of notes, it's going to talk about more about end behavior. So our domain and range will not always be exact as a parabola. Our parabola will start and stop at certain points. So again, if you think back to projectile motion, sometimes they will start at the vertex and then just go to the right, you know, as we're throwing objects off the side of a building. Okay, hey, that's it for these notes. I will see you next time in class. And you know what? We will do this in class together. Alrighty, bye.